Hello guys, welcome back to Maths on African Motives. Still working on our mathematics N5, working on the revisions from our August 2023 exams. We are going to be focusing now on question number 6, whereby we have got our differential equations in this case. So given the first part of our question was to determine the particular solution. So take note there, you are dealing with a particular solution whereby you are supposed to find the constants in this case. You are supposed to find the value of the constants in this case, that is the numerical value of the constants or the constant depending with what you'll be given. If it is one constant, you have to find its numerical value. That is the continuum of a particular solution. So analyzing this, we are given that it's y dy dx is equal to 3 square root of x y squared plus 9x if y0 is equal to 4. I said in our part of our differential equations that if you are given this particular statement, you are given to say the value of y, which is 4, is corresponding when x is equal to 0. Just like f of 0 is equal to 4. Remember, from our function, f of x is written in terms of x, to say f of x is equal to x squared plus this. So if you substitute 0 in that condition, you obtain y being a 4. So that is what they are saying in this case. So there we are given the value of x in this case, which is equal to 0 when we are given the value of y when x is equal to 0. So that is, we have also the value of y there. All right. So remember, guys, this one, that is the first order differential equation in this case that we are dealing with. So from our first order differential equation, we understand that we are supposed to separate our variables in this case. We are supposed to separate, but check what we have here under the square root. So if we check under the square root, there's something here, x is common. So you can try to first play around with what is inside of the square root. So we are going to rewrite as it is the first part. So that is y dy dx is equal to, inside the square root, we can factor out the x that is common. So if I factor out this x, I'm going to remain with the y squared plus 9 in this case. All right, so this is what we are going to have on our condition. All right, so I just want to take this one up. So remember that we are dealing with the first order, which is the first degree, which is 1. So there's a first order differential whereby you're supposed to separate, like I said. Having the square root of this part, from our sets, we can separate this because we know that the square root of AB from our sets in mathematics N3, we know that this gives us the square root of A times the square root of B, meaning to say this can be separated as the square root of x, the square root of y squared plus 9. We can separate the part under the square root so that we have the part of x and the part of y separated. So this is going to be 3 square root of x by the square root of this part, because here we are multiplying to this bracket. So we are going to have the square root of y squared plus what? Plus 9. That is, we have used this law from our sets. Now from this part, we can separate what belongs to y to dy in this case, what belongs to x to dx. But what can we do now from this stage? We can simply cross multiply the first stage because this is same as over 1. So you can cross multiply so that will be 1 times y dy, which is y dy is equal to dx is going to multiply the whole of this part here. So it is going to be 3 the square root of x, the square root of y squared plus 9 in this case, multiplied to what? Multiplied to dx. So remember, on our separation, we have to take this y with respect to y in this case. So definitely, we are supposed to divide by this part. Since we are multiplying, we are supposed to divide by the square root. So this one is going to be y over, we divided by the square root, so it's going to be the square root of y squared plus 9 like this, with respect to y is equal to, once we divide by this square root, it means we are left with the 3 square root of x dx in this case. So we're going to be left with the 3 square root of x dx with respect to x. What is the purpose of separating these? It's because once we have separated y to y and x to x, we can be able to integrate now both sides of our equations. By integrating, we are finding at least an expression that we can deal with what? With x and y. So that is how we remove this dy and dx, by integrating both sides. So meaning to say, it's you now, it's up to you now, it's you and your basic integrals at this moment to say, how do you integrate, how are you going to integrate y over the square root of y squared with respect to y? All right, so let us just have our calculations here, because we are supposed to integrate this part here. All right, so we are supposed to integrate this part. So let us start with this part here. We are here supposed to integrate y over the square root of y squared, of which the square root of y squared can be given as we can take this part as just y plus, that is y squared plus 9 to the exponent of a half in this case. That is to represent what? To represent a square root, or we can just take it as it is. So here we can just take it as y squared plus 9 like this to the exponent of a half, like this to the exponent of a half. So take note at this stage, this is what we are supposed to integrate with respect to y, of which by checking here, we can see that this is being raised to the exponent, and we have a y, and if we differentiate y squared, it gives us 2y, which can actually cancel with this y at the end. So meaning to say, we can try by all means to use our substitution, where we can let our u to be equal to y squared plus 9 in this case. So if we let u be equal to this, we are going to find dy, du, dy in this case, which is going to give us 2y in this case. All right. So what is the purpose here of finding this? We want to make dy the subject. So we are going to simply cross multiply. That is going to be du is equal to 2y times dy like this. We divide by 2y both sides, by 2y both sides. So that will cancel. So dy is simply equal to du over d over 2y like this part here over 2y. So this is the part that we are supposed to now substitute in place of dy. We are going to substitute du over 2y like this. So we're going to have the integral of y over, remember we said this whole part is now represented by u. So it is going to be u to the exponent of a half. All right, multiplied to dy in this case, which is this part, which is du over 2y. Okay, so from this part, as you can see, y and y is going to cancel. We can take the 1 over 2 outside of our integral. So this is going to be equal to, so we're going to have 1 over 2 outside of the integral. We remain with 1 over u to the exponent of a half, which is same as u to the exponent of minus a half on top, so that we can be able to integrate this with respect to u. All right, so meaning to say, this is going to give us a half multiplied to, we can integrate. So remember, on our integral, we add 1 in this case. So that's minus a half plus a 1, which is going to give us a u to the exponent of a half over the new exponent, which is our half in this case. All right, so this is what we're supposed to have, whereby if we simplify properly, it was going to be half times 1 divided to this half here is going to give us a 2. So it's going to be 2u to the exponent of a half like this, whereby this and this will cancel. We remain with the u to the exponent of a half, whereby our u is represented by what? By this part. So meaning to say, after integrating this whole part, we are going to remain with the u to the exponent of a half, which is y squared plus 9 to the exponent of a half, which is simply the square root of this part. That is the one that you're going to obtain. All right, so here we are going to obtain y squared, that's y squared plus 9 to the exponent of a half. That is after the whole integral of this side. So this is equal to, you do the same, you integrate this part. So we are going to integrate this part with respect to x. So let us see what you're going to have at the end if we are to integrate with respect to x. All right, let's just remove this part here. So we are now given our expression. This part that we are supposed to integrate is the integral of 3 square root of x. The square root of x is same as x to the exponent of a half. All right. So meaning to say here, we are going to simply add a 1 on our exponent, which was going to give us 3 over 2. Okay, so we're going to have 3x to the exponent of 3 over 2. Remember, you divide by the new exponent, which is 3 over 2 in this case. So if we divide 3 over 2 divided to this 3 over 2, we are going to obtain a positive 2. So that's 2x to the exponent of 3 over 2. So meaning to say here, after integrating, you're going to obtain 2x to the exponent of 3 over 2 plus the constant now of your integration in this case, which is c. So from this part, we are having a general solution. When we have this is our general solution in this case. So what are we going to do? We are going to take back our limit, the values of x, the value of x and y that we are given, so that we determine exactly the particular solution, where I said you have to find the value of the constant or the constants that you are given depending with the question. So to find the value of the constant, that's where you have to substitute the value of x and y from this condition. Y0 is equal to 4, where we have got x being 0 and y being 4. So y in this case, that's a 4. Wherever there is a y in this case, we're going to put a 4. So this one is going to give us 4 squared plus 9 to the exponent of half, which is same as the square root, all right, which is equal to x at that moment, it's a 0 in this case. Remember, our x there is a 0. So once we substitute a 0 in this case, that's 0 to the x, but that's a 0 there. So we are going to just remain with a c. So from our calculator now, we are supposed to simplify this part properly. All right, so let us check on our calculator here. We've got a bracket, or we can just put the square root at once. It's the same. So that's 4 squared plus 9 to the exponent of a half, which is same as the square root. All right, so we are going to obtain a 5 in this case. All right, so 5 is equivalent to c in this case. That is, our c is going to be a 5 at the end. So having our c equal to 5, we are going to substitute back into this expression that we had where there's a constant. So we are going to have this. Remember, I said it can be written as the square root of. So you can write this as the square root of y squared plus 9 from this part here is the same as the square root of, all right, which is equal to this one. Also, you can write as a square root, or you can just leave it like that. That is 2x to the exponent of 3 over 2 plus the constant now, which is a 5. So now we have a particular solution from this part here. We are now representing what? A particular solution by finding the constant value. That is the value of the constant. That's how we play around this part. All you just needed there was to separate properly and integrate both sides as given. All right, so let us check the other part of the question, which is on 6.2. Again, we are asked to determine the particular solution of this integral. That is, now we are dealing with the second order in this case. So let us analyze first here what we have. We are going to talk about the finding the solution part, but let us analyze what we have on this part here. We are given that dy dx is given on a condition where x is equal to 0 is equal to 3. So we are given that where x is equal to 0, our dy dx is equal to 3. That is what they are simply saying there. To say x is equal to 0, at that moment, our dy dx is equal to what? Is equal to 3. We are back to that same condition of our last time. Y1 is equal to 2. We are given the value of x there to say when x is equal to 1, y at that moment is going to be equal to 2. So this is what it simply means. All right. So dealing with our second order, we know that we are supposed to integrate throughout until we obtain our final solution for y. So in this case, we're supposed to integrate this with respect to x. We also integrate this side with respect to x. But checking what we have on the right-hand side, we see that it's difficult for us to integrate this part direct because we are supposed to find it stage by stage. So what we can do is to expand depending if you can integrate it as it is like this because we have the concept, the formulas that can integrate this part as it is. But here we are supposed to expand our brackets, have it in a normal function of f of x that we understand. All right. So here let us try to expand first. All right. So we are going to try to expand. That means the second derivative with respect to x is equal to 2 into, you expand this x minus 3 squared. So you can use the concept. Remember that a minus b squared is equal to a squared minus 2ab plus b squared, whereby this is our a, this is our b. So we're going to have a, which is x squared minus 2 times our a in this case, which is x times our b, which is 3 over 2. All right. So this and this will cancel. And the last part is b squared. Our b is 3 over 2. So it's going to be 3 over 2 squared. So meaning to say you're going to have x squared minus 3x plus 3 squared, that is 9, 2 squared, which is a 4. So you're going to have this part. Or you can simply expand your brackets, 2 brackets, x minus 3 over 2 into x minus 3 over 2. Expand properly x and x, that will be x squared, x and minus 3 over 2, that will be minus 3 over 2x. We are done with x. You move on to minus 3 over 2 here times x, that will be minus 3 over 2x, minus 3 over 2 and minus 3 over 2, negative, negative, that will be a positive 9 over 4 if you multiply. You collect the like terms here from your calculator. This was going to give you a negative 3x in this case plus 9 over 4. So that's how we can simply have it. So meaning to say this whole part here is going to give us x squared minus 3x plus 9 over 4 in this case. All right. Then we are going to subtract a half at the end. So this part, we are going to subtract a half at the end. So this is what we're supposed to deal with first. Expand your brackets. Again, because we have got a 2 in this case, which is going to expand everything inside the bracket. So this part we are going to have, again, our second derivative with respect to x, that's 2 times x squared, which is 2x squared, 2 times negative 3, which is going to be negative 6x, 2 times 9 over 4. This one was going to give us a 9 over 2 in this case, minus a half. So as we can see here, we can simplify by collecting our like terms. Here we've got 9 over 2 minus a half. So from our simplification from our calculator, this was going to give us a 4 at the end. So meaning to say we are having the second derivative of y with respect to x as 2x to the exponent of 2 minus 6x plus 4. This whole part from your calculator is going to give you a 4 in this case. So as we can see, this was the hidden part of our quadratic expression. This is the f of x that we're just given, a normal f of x that we are used to. So now you can apply your integration properly, because here we want to find y at the end. So how do you deal with the second order? You integrate throughout with respect to x. Like I said in the first place, we are supposed to integrate this part with respect to x. You integrate this part with respect to x. So meaning to say, if you integrate the exponent of 2 from your dy dx, you obtain dy dx. This is the second order. You go back to the first order, whereby you're going to have dy dx, all right, which is equal to, you integrate this part. Remember, you add a 1 here. So you're going to add a 1, which is going to be a 3. So you're going to obtain 2x to the exponent of 3 over 3. Minus, we move on to this part of 6. It's already a 1, so you're supposed to add a 1 here, which was going to give us negative 6x squared over 2. Divide this one, it was going to give us a negative 3. So that's negative 3x squared. The integral of a constant, which is 4, is going to give us 4x with respect to x. So we're going to have 4x plus the constant. So the first constant, we can name it A. So because we are given two conditions, so we're going to have the first constant, we find its numerical value because we need the particular solution in this case. So this one that we have here, where A is the unknown, is the general solution. So this whole part is your general solution. So you need to determine the particular solution. Where do you find it? What are you given, or what are you having here? You are talking about dy dx in terms of x. So that is where we go back now. Dy dx in terms of x. So we are given that in terms of dy dx, this is the condition. Dy dx is equal to 3 when x is equal to 0. This is what we have here, that dy dx is supposed to be equal to 3 when x is equal to 0. So in place of dy dx, we are going to substitute a 3 in this case, all right? So where there is dy dx, we are going to substitute a 3. And where there is x, we substitute a 0 in this case. So this whole part was going to give us a 0. So we remain with the a in this case being equal to what? Our a being equivalent to 3. So with the value of a, we are going to substitute it back. So we now have dy dx is equal to 2x to the exponent of 3 over 3 minus 3x squared plus 4x. We now substitute the a that we got, of which our a in this case is what? Is 3. So this is going to be a 3. Remember, we need to find the value of y. We integrated when we've got the second part or second derivative, we got dy dx. So it means we are going to apply the same concept. We have to integrate dy dx with respect to x. We also integrate this side with respect to x. The moment now we integrate dy dx, that's where we are finding the value of y, or the expression for y. Because we are talking about y with respect to dy dx, we just left with the 1 dy dx, all right? So we are obtaining y from there. From this part, we are integrating again, just like the previous part. We are supposed to integrate each and every part. So remembering our integral, we add 1, so it was going to be 4. So it was going to be 2x to the exponent of 4 over the 4 multiplies this number in the denominator. So it's 4 times 3, which was going to give us a 12. As you can see, this was going to give us 1 over 6 at the end. So we're going to obtain x to the exponent of 4 over 6. Minus, we do the same thing here. We're going to add a 1, which was going to give us a negative 3x to the exponent of 3 over the new exponent, which is 3. So this one and this one was going to cancel. We remain with minus x to the exponent of 3. We do the same thing on 4. We already it's a 1, so we add a 1. So it was going to give us 4x to the exponent of 2 over 2. So this and this cancels. So we're going to obtain 2x squared in this case, all right? So this was going to give us 2x squared. The integral of a constant with respect to x, that was going to be x. We add the constant of integration. The first part was a. This time we are going to use b. All right, so this is where we are now having an equation that is representing y, an expression for y. So just like the previous case that we had, we are supposed to consider y this time. The previous part, we considered dy dx, we substituted the value of dy dx, the values of x. This time we are considering where we are given y. What is the condition for y in this case? We are given here the condition for y is that y is equal to 2 when x is equal to 1. This is the condition that we are working with for y. Y is 2 when x is 1. So meaning to say, where there is y this time, that is where we are supposed to substitute a 2 so that we find the value of b, which is the unknown. Where there is a y, that is a 2. Wherever there is a x, so this was going to be 1 to the exponent of 4, 1 to the exponent of 3, 1 to the exponent of 2, and here you substitute a 1. Wherever there is an x, you are going to substitute a 1 in this case, wherever there is x. So this was going to give us at the end, if you combine your right-hand side, you're going to obtain 25 over 6 wherever there's x, plus b in this case. All right, so transpose the 25 over 6 to the other side, you subtract. That was going to give us negative 13 over 6. So that was negative 13 over 6 equal to b. So therefore, at the end, we are going to say our y in this case is given as, we substitute now back the b that we got. So that was going to be x to the exponent of 4 over 6 minus x to the exponent of 3 plus 2x to the exponent of 2 plus 3x plus the b, which is our b, it's a negative 13 over 6 in this case. So this is the particular solution that we are obtaining y in terms of what. So they can ask this question as express y in terms of x. It is the same question as determine the particular solution. You determine the values of the constants. This time you are supposed to calculate your constants, whereas if it is a general solution, you leave your answer in terms of constants. You do not determine the numerical values. You just leave your answer as the constants in this case. All right, so that is how we were supposed to play around with these typical questions. Just have to revise as much as you can so that you prepare enough for the exams. It just needs us to work with more questions, more question papers that can actually help us to prepare enough for the exams. But for now, that's it, guys, till we meet again.